All right, so in this problem, what I have here is says a flat, unbanked curve on a highway has a radius of 80 meters, and a car rounds the curve at a speed of 17 meters per second. Must be the minimum coefficient of friction to prevent sliding? So the first step in solving these problems is to do your free body diagram. So the circle that I've drawn here, this circle represents the path that the car is going to go through. Okay, so the reason why I flatten it is to represent it as a horizontal rather than a vertical circle. When we do vertical circles, we're going to make it look like an actual circle. So this is like looking at it from the side, so it looks sort of horizontal. And so the forces on here, the only force that's going to change the direction of the car is the friction between the tires and the road. So that's the friction. But anytime friction is one of your forces, it probably means that we're going to also want the normal force, because we have that formula, friction equals mu Fn. So if friction's there, you probably also want to identify what your normal force would be in this problem. And in this problem, the normal force would be like this. So I'm going to have the weight in one direction and the normal force in the other direction. So that's the normal force, and that's the weight. And I hope some of you did these problems prior to the time that I'm going over these, because if you didn't, like I said, you're not learning physics by watching me do it. So this is just to courtesy to you that, okay, I want to see that I did things correctly. And if you didn't, physics is something that should be a little bit aggravating for you. That you're doing a problem and you might have to talk to 2 or 3 people and figure things out. But when you figure it out, you're going to know it. If you just sit there passively and watch me do it, you're not going to learn it. So after I have my diagram, then I can write my descriptive equations. So I'm going to sum up my forces in the centripetal direction. Now, it's not considered the x direction, it's the centripetal. Because if the car is over here, the arrow would be to the right. If the car is over there, the arrow is to the left. So it's not the x direction, it's the centripetal direction. It's always in the direction that we're changing direction. So if we sum up our centripetal forces, the only force that we have that's changing the direction is friction, and that's going to equal either mv squared over r or mr omega squared. Both of those are ma. When I say F equals ma, both of those are ma. But I would suggest that you always use, unless the radius is the unknown, and the radius isn't the unknown, it's given. So I would suggest you use mv squared over r. And the reason why I prefer that is because I don't like to use omega in radians per second unless I have to. Because the radians sometimes doesn't cancel out. You'll see in the next problem it doesn't cancel out. But, this is going to be in kilograms. That's going to be in meters per second. That's going to be in meters. So I will produce the units, newtons, for my force, my frictional force. Now, if we sum up our forces in the y direction, because we do have a y direction, it's vertical, it's perpendicular to the centripetal direction, we're going to have Fn is up and W is down. So Fn minus W equals 0. Now, the reason why that's important is because if Fn minus W equals 0, then I can say Fn equals W. And W equals mg. So if Fn equals W, and if W equals mg, then I can say Fn equals mg. All right, so these two are equal. And the reason why that's important is I'm now going to replace friction. I'm going to write friction as, we know friction is mu Fn. So I'm going to write friction as mu mg. So if you look on the board, I have friction equals mv squared over r, and I have friction equals mu mg. So if friction equals that, and if friction equals that, then these two are equal. So I can make a new equation that has mv squared over r equals mu mg. So I'm really just manipulating variables. And this is another reason why I've been telling you all year, don't plug in the numbers early. Work with the variables. It's actually easier to work with the variables, and we'll worry about what the numbers are at the end. Now, what can I cancel on both sides of that equation? M. So the mass doesn't matter. Like the mass is not, it doesn't matter whether I have a 500 kilogram car or a 1,000 kilogram car. No matter what it is, the answer will be the same for what the coefficient of friction has to be. Right? And remember, that represents how slippery the surface is. So mu is the unknown, so I'm just going to rearrange this equation to solve for mu. So all I have to do is move the g down there, and I'm done. So mu is going to equal v squared divided by rg, or divided by gr. Doesn't matter what order. So the good thing about this problem is they gave me the v. Like I don't have to convert. A lot of these problems, they don't tell you what the v is. They give you like the angular velocity, and you'd have to do a conversion. But this one is nice and convenient because I don't have to do any conversions. I'm going to have v squared over rg. So for the v, I'm going to put in 17 meters per second. For the r, I'm going to put in 80 meters. And for g, I'm going to put in 9.8 meters per second squared. So putting all those numbers in, the answer for this came out to be 0.369. And notice that all the units cancel out because I get meters squared per second squared, and meter times meter is meter squared, so meter squared per second squared, top and bottom. So I know this was done correctly because I know that doesn't have any units, and if I do this, I won't have any units in my final answer because everything will cancel out. All right, any questions with that one? The next one's a little bit harder than this one, but it starts the same.